Sorry? It's when, oh, you already done with the quiz? Oh, you done with the quiz, okay. So you are starting technically exponential function. Okay. All right, I need to record that somebody's away, but I'm gonna go back to Kasha is attending one of the, I would say the schools gave you a difficult question on the assessment. I won't say all the questions, but it's a challenge because a large Asian parents. So we're gonna going back to some question that she didn't answer is correct. So we're gonna going back to the first one you guys gonna do for practice. So if what is your name, sir? Kaushi, okay. So we're gonna go back. You might recall this question from your previous semester. Choose the correct expression for f inverse of x. Choose the correct f inverse of x. Harsha, if you made a mistake on this question, it's an easy question. So I'm not sure how come it's went wrong. You choose completely wrong answer. We did talk about how to find the inverse. Let's ask Adre. How would you find the inverse, Adre? Sorry?
Oh wait, no, you swap the x and y.
Okay, so you swap the x and y. So you're gonna swap the x and y and then solve for y, isn't it? So x plus 6 is equal to 3y. So y is equal to x plus 6 divided by 3. So what your teacher have done is on the multiple choice, they have flipping the answer. You can divide each one of them by 3, which is going to be 1/3 of x plus 2. Right? Make sense?
Yeah, I just deducted the x plus 6 divided by 3.
Or you didn't divide it by 3. Okay. You didn't divide it by 3. You choose 1/3 of x, 6. 1/3 of x plus 2. You choose the answer that is not divided by 6. So what's happening? This is the final answer, but they didn't really give the final answer on that form. So if I have a plus b divided by 5, we can rewrite it a over 5 plus b over 5, isn't it? Because 5 is the same denominator, so you can split it. Where are you guys in grade 10? Oh, you have a quadratic relation. How's it going? Are you using it?
Yeah, I just had my test on Friday.
Easy? It's a properties of the quadratic relation or it's the factoring?
Just properties.
Okay, vertex.
Yeah.
And then writing the equation, describe the transformation. Do you guys learn step pattern?
Yeah.
So how's you doing, sir? What's your updated math mark?
Still being updated.
It's just as from last class when you're getting the report card midterm. Okay. So let's going back to the next question. This is a nice warm up from this unit. Where are you in exponential function? Are you guys done?
We're doing our quiz now tomorrow.
And quiz on which section? 4.1.
It's just like the graphing of the exponentials.
Also graphing. We will catch up on the graphing today so you can able to see transformation. So next question is asked was there are 2 questions. A radical function. So radical function. So let's going back to Kavya. What do you mean by radical function? How that look like? That's right. So square root function. So parent function that. So has been vertically compressed by a factor of 1/2. So compressed by 1/2. Reflected in the y-axis. Shifted right by 1 and down by 2. So how do we do that? Y is equal to 1/2 of root of reflected on the y-axis, so there'll be minus come in, and shifted to the right, x minus 1 down by 2. So you lose 1 mark because you didn't put the bracket. Okay. Interesting. And then it's down by 2 unit, mean that should be minus. Okay. So that's 1 mark. You lose 1 mark. Multiple choice, you lose 2 marks. And then the other one you got it right. So you got the other one right. So that's all together 1 mark. On the same grid for the inverse, or you didn't use more point, you didn't choose more points. Okay. Okay, so far I see that silly mistakes. So next one. Oh yeah. Back to the next question. Given the transformation minus 2f, 1/3 x plus 1, minus 5 applied to the function f of x. So apply to f of x. If f of x has a point 5 comma minus 3, find the transform coordinate. So if f of x is a point on the transform function, determine the corresponding point on the original function. Oh yeah, so if this is in transform 5 comma minus 3 point in the transform function, find the original point.
When I realized at the end, like I came back to and I realized I had to change.
Okay, so we have done this question before, so isn't it, for your function test? You say we didn't do on your function test in last year.
Oh,
The
yeah.
test that you didn't do well on, your teacher gave you
Yeah.
a makeup test I went through. Remember that function test, the whole class didn't do well?
Yeah.
And then I have a good memory, man. Okay, I can tell what happened in my grade 2 math class. Okay, so let's going back to what is this question. So this is a real challenging question. So do we know mapping notation? Did we talk about mapping notation? So are you calling Gaussian? You say Gaussian, right? Gaussian, yes. Have you heard about mapping notation? Have you heard about mapping notation? So what is the mapping notation? If I want to go from x comma y, how does this work? How do I map it? Kavya, mapping notation. We learned in the beginning, long time ago. Yes, sir.
1 over kx
Yes, 1 over kx. So x over k, yes.
ay plus c
Plus x over k plus what?
plus d.
D, yeah. Ay plus c, isn't it? Make sense? The question to find x comma y on the original one, right? X over the k is 1/3, isn't it? Are you following that? So 1/3 mean it's going to be 1/3. I will write 1/3. My d value is going to be minus 1. Ay minus 2y minus 5, isn't it? So let's do that other way around. X comma y is supposed to be, it goes up 3x minus 1 comma minus 2y minus 5. Are you seeing that? They say 3x minus 1 is equal to 5. And they say minus 2y minus 5 is negative 3. Solve for x. 3x is 6, x is 2. Minus 2y is equal to negative 3 plus 5. Minus 2y is equal to 2. Y is equal to negative 1. It's not difficult if you just need to know the mapping notation. When you know the mapping notation, that's take you 2 marks out. So where else do you lose your marks? So you see somewhere, okay. For the function below, complete the given f of x and f inverse of x. Oh, okay. We have done so many questions how to find the f inverse of x. Let's give these guys a question. All right, your question for you, find f inverse of x for the following function. Minus 1 over 4, 3x minus 6, whole thing squared plus 3. That's the last question. We will talk about the domain and range.
I did the question back. She's in algebra.
Yeah, yeah, you made a mistake on the algebra. So how would you improve the algebra?
Do more questions.
More practice. I'm going to show you where to get more practice. Okay, so let's see if you guys can find the inverse before we move on. So I'm going to move back to, where is your friend, Will? You guys don't talk to each other at school? He's a latecomer. That's okay. All right. I want you guys to see how would you guys, why don't you do that again for your practice? Find the inverse. Notebook. Let's see how would you guys find the inverse of that function. Correct. First step is correct. F, that's right. We need to take the F of X and change it back to Y. How are you doing in math at school? 60s, 70s? Where are you?
I'm like, you didn't update your marks yet, so
I can't see it.
yeah, so you didn't update your marks. We had a quiz like last week.
So you said you don't know your file, right? Current mark.
Yeah, I have like a 60 something.
Okay, yeah. Well, you should know your skill set at this point. Okay, so let's see how we define the inverse. Any TDF student, I can access their marks, so they can't really say they don't know their marks, even though I'm not teaching, I can access. If they're using the right space, the D12. What's going on, sir? X plus 3. Why don't you cross multiply by 4 rather than doing that idly? Right? Yeah. Okay, let's see. So you're missing the first step. What is the first step in finding the inverse? Yeah, so then why you're writing Y again? Let me see, sir, how you doing? Where are you at school?
We have a rational function test tomorrow, and we started trigonometry.
You're starting trigonometry on Friday.
We started it, and
Oh,
we have a test tomorrow.
okay, let's see, how did you do this? Where is your work? Let me see the steps, man. Minus. Where did you get -3? Oh, that -3. What? I'm not sure why do you just want to divide it by the -1/4. Why don't you do, Kevin, are you doing the work, sir?
Yeah, I'm doing it in my notebook.
Okay. So let's see, how's your algebra going on? Even after the test, you should know how to do it nicely. Let me see. You'll be in big trouble at home today. Dad is going to be asked to do 2 hours of math per day. That's okay. Okay. So the problem is that the way you guys doing the algebra. So I'm not sure why do you want to do in a longer way. So let's going back to y is equal to -1/4, 3x minus 6, all things squared plus 3, isn't it? So second step is we're going to be exchange x with y. So this is supposed to be -6 whole thing squared plus 3. Of course, the first step is to moving the 3 to the other side. So that should be done nicely. X minus 3 is -1/4, 3y minus 6 whole thing squared. I didn't really get it. Why are you dividing by -1/4? Come on, guys. It's just dividing by 4 means cross multiplied by 4. Why do you want to divide it by -1/4? Can you cross multiply by the 4 to get it out that? So that is going to be 4 times x minus 3 is -3y minus 6 whole thing squared. Of course, I don't need the -1, so I'm going to divide it by -1 both sides. So that is 4 times x minus 3, 3y minus 6 whole thing squared. So we need to get it up there, square, isn't it? So Kevin, what should I do to get it up the square?
Wait, I can't see your screen.
Oh no, what happened to my screen share? Okay, so this is done, screen share. Okay. Okay, here we go. So how do I do the next step? What should I do to get it up the square?
You square root both sides.
Square root. When you do the square root, you're gonna be get plus or minus sign 3y minus 6. Something cool I can do. Do you guys see the 4? The 4 come out of the square root is going to be plus or minus 2, isn't it? Are you guys following that? We need to solve for y. So what do we do to solve for y? We're gonna move the 6 to the other side. I made a mistake. The 2 is outside of the square root. That's not right. The 2 is outside of the square root. So we have to keep the 2. We have to keep the 2 outside. X minus 3. 3y. Now I need to get the y. So I'm going to divide it by 3. So that's being said. The f inverse of x, we find it. 6 plus or minus 2 square root of x minus 3 divided by. Make sense? Are you following the logic?
Yeah, but are we able to keep the 4 inside, or do we have to?
Well, that's a good question. Your teacher will expect you to simplify as much as possible, right? So you better need to take the 4 out of the radical, because before that you learn how to simplify radical expression. All right. You didn't write that unit test on this yet?
We
This
had
is
the
the-
unit test. I think
This
just
is the
left it-
quiz.
I think I just left it at home.
So did you get that back too?
Yeah, it should be.
So how do you do on that?
That one was around, I think, like a 74.
Okay. All right. I need to print you the handout so that what we are working on, and then we're going to be continuing back to where we are. So let's get the handout. It's exponential function. Did I give you the handout for exponential function? Okay. So you were away. So MCR3, where's my MCR3 package ACI? Yeah. So that's a whole lesson package. So let's, because you were online last class. You were online last class. Oh yeah, everyone is online. What happened just last class? Just last class you were not here?
No, because it was too icy.
Oh yeah, it's an icy weather, yes. So you also join online. Oh yeah, okay. Online. All right, so that's 1, 2, 3, 4, 5. You have the copies on it, sir? Yeah, that's gonna come in. So we're gonna moving back to today, talking about. So we did a lot of stuff with the exponents last class. So I'm gonna moving back to the graphic parts. I'm gonna coming back to the graph parts, and then we will revisit solving exponential equations. So why am I? Okay, it's loading. All right. So we're going to talk about exponential function. So to talk about exponential function, what we're going to do, we're going to going back to right, looking at some base function, and then fill out the table of values. Without calculator, let's see, Gaussian, what is 2 to the power of 3 is going to be? All right. Let me go back to Gemini. Can students learn high level math without knowing the timetable? You guys are an AI, so AI need to tell you. Theoretical student can learn, but it will make the learning journey significantly more difficult, slower, and potentially more frustrating. You won't believe me, you won't believe the teacher, but you guys in the AI age, I was testing out why Ontario students are struggling in math. It's given me some interesting insights, especially put the blame on not enough trained teachers in elementary school. It's true. That's where the problem starts. So this one, you know what is 2 to the power of 3 mean? It's 2 multiplied 4 3 times, isn't it? So which is 8. 2 to the power of 2, 2 to the power 1, 2 to the power 0, 1. Now 2 to the power of -1, what I'm gonna do, I'm gonna rewrite in positive exponent form is 1/2. 2 to the power of -2 in positive exponent form 1/4, 2 to the power of -3 positive exponent form 1/8. What we want to do is we want to take the first difference. To do the first difference, we're going to be first calculate these numbers. This is 0.5. This is 0.25. This is 0.125. I know you're expert in first and second difference. I'm not really worried about it, because it is not going to be equal. But let's find a ratio. 0.25 How do you find a ratio mean? We're gonna find 1/4 divided by 1/8. If I divide 1/4 divided by 1/8, how much I will get, Kavya? How many 1/8 are in 1/4? 4. All right, let me first distribute this. You can use a calculator for that. It's not a problem on that. Using a calculator. All right, so that's my first package. Let's look like a big package for sure. Yeah, copying. No, just look like that. 2 packages to join together. That's fine. Review. That's fine. Oh no. Oh no. Oh, but I have good news is I have the clip. Sit. Oh, you got it. So you can give it to Aaron. And then you came to my class. Oh, you also. Oh, yeah. You're that. Okay, pass this. All that. All right, here we go. So if I'm going to take this, if you guys do the division, let me do the sum recall of the scale 1/4 times it by 8. Because when you divide it, we can flip the fraction, we will get 2. And then you can see the difference are going to be all 2 if you do the math. Example, 8 divided by 4. If you just try to find it here, 8 divided by 4 is supposed to be 2, isn't it? Let's go back to the next one. So what is 3 to the power of 3, Kavya? You're allowed to use a calculator. Use a calculator. 27. 3 squared is? Let's go back to Gaussian. Correct. And 3 to the power 1 is? 3 to the power 0 is? 1. 3 to the power negative 1 is 1/3. 3 to the power negative 2 is 1/9. 3 to the power negative 3 is 1/3 to the power of 3, which is 1/27. Of course, the first and second difference are not going to be the same. If you take that ratio between 1/9 divided by 1/27, it's actually going to be 3. You can check the math. That ratio will be the same. Are you following that? So going back to this guy, 1/2. The 1/2 of x is a little tricky. Because if I do 1/2 to the power of negative 3, this is, in fact, 1/2 to the power of negative 3. And then leaving that negative exponent, the positive exponent, yield 2 to the power of 3, which is 8. So I will do that. I will skip the step. That is going to be 4. I will skip the step. That is going to be 2. This is 0. This is 1/2. This is 1/4. This is 1/8. But let me show you the ratio. If I divide 4 divided by 8, I'm going to get 1/2, isn't it? Yes, sir.
Isn't it when it's 0, it's 1?
Oh, yeah, it's 1, man. Thank you. So the rest is going to be 1/2, 1/2, 1/2. I don't want to fill the table, but let's do for practice. This is 1/3 to the power of negative 3. Is 1/3 to the power of negative 3. It's going to be 27. This is 9. This is 1. I mean, this is 3 because 3 to the power. 1/3 to the power of negative 1. This is 1. 3 to the power of 1 is 1/3. 1/9. 1/27. If you take the ratio, 9 divided by 27 is going to be 1/3. And then if you do this one, all going to be 1/3. So if you guys see the 1/3, what the 1/3 telling us, the 1/3 is the base, isn't it? 1/2 is the base. And then 2 is the base, 3 is the base, isn't it? So the ratio between the adjacent y values are the same, the modulus exponential function. So we talked about last class, there are several examples can be modeled by exponential function. Oh yes, I'm missing Tivia. So Kevin already told me. All right. So can you give me an example? A situation can be modeled by exponential function. So an exponential function create a shape like this. You will either have a shape goes like this, or either have a shape go like this. These are the two example model of exponential function. Where did you see them?
COVID cases.
COVID cases. The number of COVID cases can be modeled by exponential growth. Where did I see this one? Second one. We will see that soon.
The COVID cases going down.
COVID cases all done. But I say we will see this soon.
Inflation.
You say inflation? I wish inflation is modeled by this. That would be cool. The economy is strong. Inflation is going down. We have an inflation going the other way around.
Gas prices.
Carbon tax cut the gas prices on taxes. Right now, gas prices going down, but it doesn't go exponentially down. Okay.
Stock market.
Stock market, yes, stock market is just exponentially going down. Another one related to stock market, as Donald Trump going war against the country's trade war. The trade war will be exchanged back to real war. So that is going to cause the third world war, and the population of the world will become like that. Right. So I have a history teacher said, one time people asked Albert Einstein, how would the third world war look like? Because he was masterminded guy behind a nuclear power and nuclear weapons. So Albert Einstein respond and say, I don't know about third world war, but I know for sure fourth world war, if there's a fourth world war, people will be fighting with bows and arrows. So that means third world war will bring a complete disaster for the humankind, and then you're going to start from the ground. All right. So what we want to do is we want to sketch this. So sketching this is going to be a little ugly, but we will do it. So you have the numbers already. Let's start from that first graph, 2 to the power of x. So when you get a -3, 0.125. Oh yeah, 0.1325. It's not easy to point it. So when you got -3, 0.125. So did you guys see that the scale factor, the 1 is divided into, so there's going to be 3 pieces for the 1, then another 3 pieces for 2. So it's going by, so each one of them is around 1/3. But I'm not really worried about pointing that guy. So let's going back to pointing -2. -2.25. So where would the 0.25 will be? -2. So 0.25 is somewhere in the half of this. So half, this is going to be the midpoint half of this. Then I got -1 is 0.5. That's easy to point it. So that's a 0.5. 0 is 1. 1 is 2. 2 is 4. 3 is 8. So how the graph is going to look like, if I'm going to plot all these points, you can see that's how the graph is going to look like. Are you guys seeing the picture? Let's do that negative. So this is going to be y is equal to f of x is equal to 2 to the power of x. I'm going to draw x is equal to 1/2 of x. Let's do that. -3, you start with an 8. So -3, you start with an 8. -2, you start with a 4. -1, you start with a 2. 0, 1. 1 is 0.5. I'm not really worried about it. I'm just going to connect the dots, so you should be able to see how the graph's supposed to be look like. Are you seeing the picture? Hello. Yes. Javier. And then obviously you can see the growth mean the graphs go this way. Decay mean is coming down. So we're going to label that. This is going to be f of x is equal to 1/2 to the power of x. So using the graph on the previous page, answer the following question. So if you guys really look at the exponential function, let's look at the domain. It is spanning through the whole x-axis, isn't it? The graph can go through the whole x-axis. Did you guys see that? It's starting from all the way on the infinity on the negative x-axis, go to positive, isn't it? So what is the domain here? No restriction. X belong to real. X belong to real. X belong to real. X belong to real. Now we need to talk about a range. So let's see. Here, does the graph crossing the x-axis? Does the graph anywhere crossing the x-axis? Correct, it is not. So what does that mean? If it is not crossing the x-axis, do you think it can take y is equal to 0? No. Does the graph below the x-axis? Does any one of the graph below the x-axis? No. So what is that telling about a range? Y belong to real, y must be greater than 0. Y belong to real, y must be greater than 0. Y belong to real, y must be greater than 0. Y belong to real, y must be greater than 0. Now, growth or decay. When the value of the base is greater than 1 is growth. So value of the base is greater than 1, growth. Value of the base is less than 1, decay. And you know the shape of the curve decay. The decay curves goes like this. Decay curve along like that. X-intercept, Gaussian. Where do you see the graph is crossing the x-axis? Yeah, x-axis. Where do you think my graphs that I draw, the red and the black, are crossing the x-axis? That's right, none. There's no x-axis, x-intercept. Here, and where do you think they're crossing the y-axis?
1.
So we're going to say y is equal to 1, y is equal to 1, y is equal to 1, y is equal to 1. Right, Kasia, why do you think is all y is equal to 1? What's the reason behind it? Why do you think all of them are crossing the y-axis, I mean x-y axis at y is equal to 1?
Because the x is at 0 and then it has to be 1 if it's to the power.
That's right. So when you have 2 to the power of x, when x is 0, that's how we find the y-intercept. Anything to the power of 0 is always 1. Now we're going to be looking at the red function. So Kavya, look at the red function. What you can think about a red function? When the x values are increases, are the y values are increasing or decreasing? Increasing. So any growth model have an increasing xy value. Any decay has a decreasing y value. Asymptote. Asymptote is where my graph doesn't touch any one of the axis or any one other point. We can see the graph doesn't touch the x-axis, isn't it? So every x-axis not touching part is an asymptote. The x-axis known as the y is equal to 0 axis, isn't it? The x-axis known as y is equal to 0 because every single coordinate, if you plug it, is going to be 0. So asymptote what is the ratio? 2, 3, 1/2, 1/3. I'm just following the pattern. Pretty straightforward graph. Carbon.
Yeah.
Okay. All right. Now we're going back to say the relationship between y is equal to 2 to the power of x, and y is equal to 1/2 of the x. It's a relationship the same between that. So we're going to see the relationship. If you look at 2 to the power of x, this one. So I'm going to be put a table of value. So this is 2 to the power of x. This is 1/2 to the power of x. First relationship. Same domain, isn't it? Same domain. Same range. Same range. Same range. This is increasing function. This is decreasing function. Same x-intercept, same x and y intercept, same x and y intercept, isn't it? Now, this is the growth function. This is the decay function. Now, the question is asking, do you think the relationship between 3 to the power of x and 1/3 of the power of x? Yes, they're going to be exactly the same because exponential functions behave the same way. It's a relation, it's a function, explain. Yes, because we can clearly see they all pass the vertical line test because they all pass. Now explain a variety of ways. How can you distinguish the exponential function from the quadratic function and the linear function? Discuss the degree table of values in graph. Well, you need to be careful here. The main difference you're just going to say, the x is sitting on the exponent, but here the x is on the base, isn't it? If you guys look at an x squared, 2x, 2 to the power of x, exists in the base, exists in the base, exists in the exponent. Yes, the degree for this is 2. Degree for this is 1. This doesn't have no degree because it doesn't have an x to the power. So we need to summarize the properties of the exponential function. The exponential function fx b to the power of x has the following characteristic. The function is exponent only if b is greater than 0 and b is not equal to 1. And then d is x belong to real. You can simply memorize that. Range is y belong to real. We have y not equal to 0. If b is greater than function, the function is increasing. The greater the value, the faster the growth. So if b is going to be greater, it's going to grow faster. If the b is going to be a fraction, the function is decreasing. The smaller the value, slower the decay, not faster the decay. B represents the growth rate. So B represents the base. This represents the growth rate or decay. The function has horizontal asymptote at y is equal to 0. So these are the general property of exponential function. So you need to know about the domain and range. What we're going to do, same thing we learned in chapter 1. Transformation. We're going to be simply do the transformation for the exponential function. Did you learn that? Okay. So we're going back to do how we can do the same thing again and again and again. AKCD. Right? AKCD. What the A is responsible for? Vertical stretch or compression, reflection. What is K is responsible for? Horizontal stress or compression, reflection on the y-axis. What is D is responsible for? Moving side to side, isn't it? What is C is responsible for? Moving up or down. Do you learn that in grade 10 quadratic relationship? Same thing again. It is going to be continual. And on mapping rule, did we learn mapping rule? Yeah, we learned mapping rule several times. So you need to memorize it. X over K plus DAY plus. X over K plus DAY plus C. So all we're going to do is we're going to use the mapping rule to graph it, but we're going to state the transformation. So Kavya, from left to right, can you tell me the transformation based on the numbers you see? Example 1.
Reflection on the x-axis.
Correct. Reflection on the x-axis, correct. You have to reflect first, correct. Yes, next.
And then horizontal translation.
How about the 2? You did the minus. So you mentioned the minus, which is right. How about the 2? What does the 2 do? Let's go to Harsha. Vertical stretch by a factor of 2, isn't it? Vertical stretch by a factor of 2. Now you're right. We're going back to the horizontal translation. Can you describe that?
Yeah, I went to the left.
Right. Horizontal translate to the right by 1 unit. So do not confuse with that. If you have a negative, you go to the right. If you have a positive, you go to the left. Mapping notation. So x over k. K is 1 in this case. Plus d. D is positive 1. So if this is minus, the d value is positive 1. Ay minus 2. Y plus c. No c value. So this is my mapping notation. So how are we going to transform x plus 1 comma minus 2y? Are you guys following that? Yes. All right. Let's fill out a table. 3 to the power of negative 2. Or no, 3. 3 to the power 0, 1, 3, 9. Oh no. I need to apply the transformation. So what's the transformation say? X plus 1. Minus 2 plus 1. Negative 1. Minus 1 plus 1. 0. 0 plus 1. 1. 1 plus 1. 2. 2 plus 1. Which is 3. Minus 2y. Minus 2 over 9. Minus 2 over 3. Minus 2. Minus 6. Minus 18. Are you seeing the picture? Get a graphic. So let's plot them in. 3 gave you negative 18. So pretty cool here. 2 gave you negative 6. 1 gave you negative 2. 0 gave me negative 2/3. 0 gave me negative 2/3. So negative 2/3 means negative 1, negative 2/3 somewhere here. Like passing the middle line. Negative 2/3 will be passing the mid. So let's show you how to estimate that. So, oops. Why it's keep on razor, small razor. Okay. So this is negative 1. And this is negative 0.5. So 2/3 is 0.67. So that's the point. Negative 2 over 9. I don't really need to worry about it. So negative 2 over 9 is going to be when x is negative 1. So negative 2 over 9, we can do the math to find out how big that is. Negative 2 over 9 should be really small. 1, 2 divided by 9, 0.22. So somewhere close here. So how that graph look like? It's need to be go through this point, this point, this point. It's just gonna go like that. It's gonna be go like that. Right? Are you seeing the picture? Oh yes, there's one more point I can use it. Are you seeing that picture? Okay. So equation of the asymptote. Y is equal to 0. Domain. X belong to real. Y-intercept. The y-intercept in x is 0, which is negative 2/3. Range. Y belong to real. But y is not equal to 0 because, oh no. Oh yes, y is not equal to 0. Something I didn't do it correct. You guys didn't say anything. Very good, thank you. I draw that point incorrect and no one say anything. Pretty cool. Everyone is watching it, pretty cool, okay. So let's raise it, What my mistake is, that point was not right, correct. This is, I say, negative 0.2. Negative 0.2 is just gonna be somewhere here. So my graph should be like that. Make sense? Hello. Okay. So range, y belong to real, but we can obviously say y is not equal to 0 because it's not crossing my y-axis, isn't it? Yes, sir.
Shouldn't it be y is less than 0?
Y is less than 0.
Because if you say y cannot go to 0, then it could be like 1 or 2.
You're right. Well, you're right. So, oh yeah, did I make a mistake here?
No, you didn't.
When I specify the domain, oh yeah, I say y is greater than 0. Yes. Y is less than 0. My bad. Y is less than 0. Yes. Okay. So, how about you guys do example 2 by yourself? I know I do have some practice. You know what? I will do this because that is a little tricky. Obviously, it is a little tricky. So, sketch the graph. But before that, I'm going to ask you to describe it. So, let's start from Arthur. Can you start to describe the transformation? What is the A value? Tell me the A value. Okay, let me go back to write the function. So f of x going through the following transformation. That's what we want to catch it. Right? Okay, what is the A value? No, I just want the A value. No, I just want the A value. What is the A value for that function? A value. Yes, sir. 1. The A is the base. This is the part of the function, guys. That's a part of the function. It's an exponential function. That 2 is not your A because it's sitting on the front. That's not necessarily mean it should be A, right? It's like take as granted. Anything sitting in the front is the A value. Make sense? Because that's your base. A value is 1. What is the K value, Kasha? Correct. All right. Kasha is right. You need to be really careful. You need to pull the -2 out. So this is going to be x plus 2 out. If you don't have a 1 in front of the x inside, you must need to take that common factor. So when I take the -2 out, okay, what is the K value? Hold on. Let's write the 2. What is the K value? -2. What is the D value?
2.
-2, lady, when this is positive. What is the C value? Okay, I helped you guys with this. So what is my mapping notation? X over K plus D. Y plus C. I will give you the value. This is 1/4. You can do the 1. You can do, this 1/4, you can write it 0.25. This is 0.5. This is 1. This is 2. This is 4. I really want to see how would you fill out a table. You take the X value, substitute here. Take the Y value, substitute here. Can you guys fill out a table and graph it, please? Yes, sir.
Why is the D value not positive?
Oh, no. If this is going to be minus in the middle, sir, if there's a minus in the middle, then the D value is positive. If you have a positive in the middle, the D value is negative. Do you see we common factor -2 out?
Yeah.
Then what do we get? We got x plus 2. So if the middle one, x minus 2, the D is positive.
Okay.
Because positive 2 means you're moving to the left side, isn't it? So therefore, my D need to be -2 to subtract. Okay, so now you can use your calculator to fill out the table, but I want you guys to draw the graph. How the graph will look like at the end. Feel free to use a calculator, do the math. You're allowed at school. But I want to see the final graph, how that looks like. So I did the Euclid math contest with my school. So I'm going to show you which question you cannot able to do. So this question, D, you need to know a logarithmic function. And then this one, D, you need to know a trigonometry. So you should have done the question number 1, sir. Question number 2, question number 3, question number 4, geometry. Question number 7, if you didn't do it, you don't know the function. That's your direct function question. Read from the table. The question somebody cannot do is this in grade 7, I mean in grade 10, if you're doing IB in 7B. And probability, you need to know the probability model. The last question, again, you need to know Pascal strength. Well, more about Pascal strength. So number 10 is super difficult, but other than that, this one, you probably didn't learn about quadratic function in more detail. Did they talk about what is the formula for the sum of the roots and then the product of the roots? Yeah. With majority of the question you should have answered, right?
Yeah.
But how come you didn't choose to do the grade 10 Galois? Why did you directly go to Euclid? The Euclid is especially for grade 12. The Galois is for grade 10. And then there's a Hypatia for the grade 9.
I didn't hear them talk about the grade 10 one.
They only talk about the Euclid. You'll have to ask the math teachers. Anyone else wrote the math contest?
I think one of my friends.
No.
And
Anyone of you wrote the math contest? The math contest is not something that it's not going to count toward your mark. If you didn't do well, no one is going to worry about it. Just looking at a challenge. Again, you calculate the values.
Oh, I calculated the value.
You got the values. Let me see if you got those values correct. So you got a 0.25 divided by -2, negative 1.25. I'm not sure how that became -2. How do you get that -2? I say plug this x value in here.
Yeah.
This x value. So if you do -2 divided by -2, what would you get? 1 minus 2 is?
Oh, yeah.
1 minus 2.
Um,
All right, let me see. So if you fill out those tables correct. 0.25 correct, and then negative 1.5, negative 1 divided by -2, positive 2 minus 2. Okay, you look like that got the curves in, yeah, right? And see if you have the values done. Okay, look like the curve is correct, yeah. That goes like that, correct, correct. Okay, yeah. So you just got the curve correct. Most of you, then some of you still playing around with the calculator. So let's get back the numbers. I say use the x values found here. So this is going to be -2 divided by -2 minus 2, which is going to be 1 minus 2, which is -1. That is 3.25, obviously pretty easy. -1 divided by -2 minus 2. This is going to be 0.5 minus 2, negative 1.5. This is 3.5. This is 0, it's easy, -2 is going to be 4. This is 1. 1 divided by -2, minus 0.5 minus 2. So it's going to be minus 0.5 minus 2 minus 2.5. 2 plus 3 is 5. 4 plus 3 is 7. 2 divided by -2 minus 1 minus 2 minus. So let's start from -3, 7. So my points are correct. Do you get the same value? All right. 1, 2. 1, 2. And then 0, 1. Something is not. Oh, what I'm plotting. I'm just plotting the wrong point. -3, 7. I'm just looking at the other graph. -2.5. So -2.5, 5. -2, 4. And then -1.5, 3.5. So if you really see it, you guys gonna see the -3 is an asymptote. Did you guys see that? I mean, +3 is an asymptote. Did you guys see that picture? Yes. The 3 is going to become an asymptote, isn't it? Does your graph pass that axis, 3? Does your graph passing the axis 3, the one I draw here?
It doesn't go below it.
Yes, it doesn't go below it, isn't it?
Yeah.
So the reason why is, in the previous one, we said the asymptote is y is equal to 0 because there's no values here, isn't it? When the last value, the c values other than 0, that is going to be a horizontal asymptote. So transformation apply, identify the following equation of the asymptote, y is equal to 3. Domain, x belong to real, no restriction, y-intercept. Y-intercept is, I don't know where's the y-intercept, I got it, so it should be, I need to calculate the y-intercept because we didn't have an x equal to 0, so we're going to calculate the y-intercept. 2 to the power up minus 2 times 0 minus 4 plus 3. So y-intercept is one half, which doesn't make sense. Why I'm doing is incorrect. There's something I'm not doing correct. Let me do my math for y-intercept. Y-intercept is 2 to the power of minus 2 times 0 minus 4. Oh, plus 3 here. So that is going to be 2 to the power of minus 4 plus 3. Of course, 2 to the power of minus 4 is really tiny number. It's 1 over 16 plus 3. So let's see, what is that? Is equal to 1 over 16 plus 3. You can put a decimal number if you want. So 1 divided by 16 plus 3. 3.0625. 3.0625. The range, y belong to real. Y is greater than, not equal to, y is greater than the asymptote, isn't it? Are you seeing the picture? Your y values are going to be greater than the asymptote. Yes? What's up? Oh, I plug it into the original equation. So the original equation given to us, the equation given to us is 2 to the power of minus 2x minus 4 plus 3. So I find out f at 0. Times minus 2 times 0 minus 4 plus 3, isn't it? All right. Now, an exponential function with a base 4, so b is equal to 4, vertically stretched by a factor of 2, a is equal to 2. Reflected on the y-axis, k must be minus 1. And translated 1 unit to the right, d must be positive 1. It asymptote is y is equal to 3, c is equal to 3. Now they say y-intercept is 0, 11. We're not done yet. So the y-intercept is 0, 11. Write the equation of the function and discuss the domain. So how that's going to look like? Y is equal to. They said, where did I get? Yes, vertical stretched by a factor of 2 times. And then base is 4. And then I don't know the k value, but all I know it should be minus x minus 1. I'm going to put a k plus 3. All the information provided to us. So c is 3. How do you know c is 3? Because it says, and there's somewhere the 3. Oh yeah, the vertical asymptote is 3. So that is going to be 3. So we need to find a k, isn't it? So how do you find a k? They say that the xy intercept is 0, 11. So 11 when x is 0. So 2 times 4 minus k to the power of 0 minus 1 plus 3. So if I move the 3 to the other side, I got 8. 2 times 4 to the power of 0 minus 1 is going to be minus 1. Times it by k is positive k. So let's divide it by 2 both sides. So 4 is equal to 4 to the power of k. The only way I can get this, k must be 1. Makes sense? So therefore, the equation is going to be y is equal to 2 times 4 minus k, x minus 1 plus 10. All right. I want to stop here to do some practice with the graphing. So the following functions, graph each one of the following functions. So there's a 1, and there's a several practice here. The next part is the application of exponential function. Pretty straightforward. We can revisit, we can go back to that. But before I move on, I really want you to do that number 1 by yourself. State the y-intercept, that the function is increasing or decreasing. using the mapping notation of graphic. I did two different examples. I did one for the basis greater than 1, basis less than 1. So it shouldn't be a problem. Kevin, do you have a number, sir?
What?
Do you have my phone number?
Yeah, I do.
Okay, can you do that and then send me the picture of the work?
Graph this?
Yeah, graph it.
Okay.
Take a ruler, make sure you just graph it properly.
Okay.
What's up? All good? Okay. We're just going to do the complete process of what we have done for the previous question. What you're thinking? Complete stuff. First, find the y-intercept. First step. Then tell whether graph is increasing or decreasing based on the b. If b is greater than 1, increasing. If the base is less than 1, it's decreasing, right? Then you have to come up with a mapping notation. So can you show me how do you find the y-intercept first? I want to see the y-intercept. So first, just find the y-intercept. Show me the y-intercept value. Let's see if you can get the y-intercept correct. So vertical stretch by factor of vertical stretch by factor of 3, and the reflection of y-axis horizontal compression by factor of horizontal compression, right? Okay, so your description is right. So let's see how you find the x-intercept, y-intercept. You find the y-intercept, sir?
3/4 minus 5.
That's a y-intercept. Oh, that's right. Yeah. Okay. You got the y-intercept correct. So let's start from then finding the y-intercept. So to find the y-intercept, you don't need to do any math. So you can substitute first y-intercept. You can substitute x equal to 0. So y is equal to 3 times 2 minus 2 x. We're going to do a minus 2. We're going to common factor that 2 out plus 1 minus 5. Every time, if you see inside, in front of the x value, if you get anything other than 1, we have to common factor. So how do I find a y-intercept? So if I call that f of x, f at 0. So 3 times 2 minus 2, 0 plus 1 minus 5. 3 times 2, 0 plus 1 is going to be 1. So minus 2 minus 5. This is 3 times 1 over 2 to the power of 2 minus 5, which is 3 over 4 minus 5. You can simplify, it's going to be negative 4.25, isn't it? Because 0.75 minus 5, are you guys following that? Make sense? Second part of the function is increasing or decreasing. Kavya, what do you think? Is this function will be increasing or this function will be decreasing? Increasing, why? What makes you to think it's an increasing function? How do you know it's above 0?
Like the base.
Oh, the base is above 0. Well, the base is above 1. Not above 0, it must be above 1 because above 0 can be fraction. 1/2 is above 0. So it is an increasing function because base, which is 2, above 1, isn't it? So the next step, we need to sketch it. You need to put the mapping notation. But before you do the mapping notation, I'm going to ask Adara, can you describe the transformation? I'm going to highlight all you need to know to describe the transformation. Can you describe the transformation, please?
Vertical compression.
It's vertical stretched by a factor of 3.
Oh, vertical stretch by factor.
So vertical is stretched by a factor of 3. Okay, Kaushik, what is the next transformation you have to do?
The reflection on the y-axis.
Correct, because the minus, reflection on the y-axis. Okay, reflection on the y-axis. Again, can you also tell me what would you do after that?
Horizontal stretch by 2.
That's where to be careful. When this is greater than 1, we're going to flip the word. So horizontally, we're going to flip the word. It's going to be horizontally compressed. Horizontally compressed by a factor of 1/2. Make sense? Okay, Aaron, the next two transformation, can you describe?
Horizontally translate to the left by 1 unit.
Horizontally translate to the left. Correct. And
Vertically translate down 5 units.
vertically translate down by 5 units, which is also correct because you're going to translate down because of the minus 5. All right. I don't want to spend on doing all the questions, so time need to be utilized here so I can keep going on finishing that. But you got 1 question, 2 questions, 3 questions to practice it. So we need to going back to the application involving exponential function. We will come back to that in a moment. But make sure you practice a graph. How is she following the lesson? Look like you didn't forget that much. So you know the things. Okay. You have the same teacher or different teacher? As her.
I'm not sure.
Are you guys in the same school? Do you guys know each other's? Okay, who taught you grade 11 math?
Her name is Miss Park.
Okay.
That's right.
You guys are probably larger school. How many students? What? Lot? 2,000? Yeah. Okay, so now we're going to be going backward to Kavya, are you following the graphing piece? All right, so the graphing piece is coming from 4.5. So in 4.5 on a textbook, on your digital textbook, you have lots of questions to practice. So I show you a textbook. If you really want to ace it, 4.5. So we're in 4.5, exploring properties of exponential function, but mainly 4.6. So you need to work on 4.6 every question. All right, 4.6. Oh, let's look like an application. Oh yeah, so that's application. We'll come back. 4.6, pretty straightforward. You can see each from the following describe the transformation. For each transformation, state the base function and describe the transformation. And so match the equation of the function from the list of appropriate graph. So you need to check. The best way to check this type of question, so look at number 9. So number 9, how do I answer number 9? First step, I'm going to looking at the vertical asymptote. So let's ask Harsha, you got 4 graphs, A, B, C, and D, isn't it? So which one do you think will match graph A? So A is, which one of the following will match A? You got 4 graphs. Oh, yes. So here's a problem with this. All of them have a vertical asymptote, horizontal asymptote at 3, isn't it? Okay. So if all of them have a horizontal asymptote at 3, then we're going to be looking at something else. So what we're going to looking at it, we're going to looking at right now the base function. If you look at the base function, we got a 1/4, isn't it? It's a growth or decay. 1/4 is growth or decay. Kavya. Decay. So decay curve supposed to be go like this. So let's see, every growth function will be ignored. So 100% sure number 1 and number 4 cannot be the answer, isn't it? Because they are all representing growth function. Do you see that? So it should be either one of the 3 or 4. Now the question here is, how do I know which is 3 or 4? I'm going to looking at the next one. There is the minus in both places, 2 minuses. So the graph must be reflected on the x-axis, also reflected on the y-axis. So let's going back to draw a decay curve that's supposed to be have an asymptote here, vertical asymptote. So this is the decay curve, something like that. It's reflected on the x-axis. If I reflect it on the x-axis, the graph goes like this, isn't it? Make sense? And then I'm going to reflect on the y-axis. If I'm going to reflect this guy on the y-axis, how the graph's supposed to be go. So let's look at the y-axis reflection. This part's supposed to go like this. This part's supposed to go like this. That's a reflection on the y-axis. This part's supposed to go like that, isn't it? So we want a shape of the graph supposed to be something like that. Are you seeing the picture? Okay, now let's go back to which one of the graph showing the picture like that. Which one can be matching? Yes, 3. That's right, 3. Look at the shape I draw. I want a graph having a shape like that. Any curve like that. Which graph showing a shape like that? 3, isn't it? Are you following that? So this can be a thinking question because you need to be able to identify the properties. Each graph represents a transform. Write an equation for each one. Oh, this is going to be a little fun. I want to do number 10. So we need to talk about number 10. MCV4U, I want to move this to my MCR3U, math temporary semester 2. Okay. I think it's moving to the right section. Hopefully it's moved to the right section. MCR3U semester 2. I'm not sure where it's being moved. No. Oh, that's moved to the wrong place. That's okay. MCR3U semester 2. Let's move to the wrong place. All right. Let's going back to the question. I can take a screenshot one more time. So let's going back to the question. This is going to be a super challenging one because they want you to write the equation in the form of that. Base function is 2, isn't it? So all we need to do is we need to find A, K, C, D, isn't it? So let's ask Adrai, what do you think the value of C is? Because the way the function transform is A, right? 2 to the power of K, X minus D plus C. What is the value of C is going to be? This is 8, this is 4, this is 6, isn't it? Are you following that? Can I say this D must be, C must be 6? Kaushik? Can I say C is equal to 6?
Yeah.
Why?
It's the y coordinate.
Not the y coordinate. Can I say C is equal to 6?
Yeah, because it must have 6 units.
So far not. Can I say C is equal to 6? Why?
It's the asymptote.
Asymptote. This is the horizontal asymptote. This is the horizontal asymptote, isn't it? Make sense? So first thing you can find out if they ask to find the equation, then asymptote. So we got the asymptote done. So we got this guy done. Now the question for us is, we should be able to find out a couple more values. So what are the values we need to find out? We need to find the D and need to find the A. So to do that, let's observe that base function. So this is 4, this is 2, this is going to be 1. And then 2 to the power, this is 4, this is 2 to the power 2 is going to be 4. Right? And then if I'm going to draw the graphs, my graph, original graph, supposed to be like that. Original graph supposed to be like that, isn't it? Now the question here is, what transformation probably happened for the graph to generate the graph? Does the graph look like reflection on the x-axis? So if I reflect on the x-axis, if the graph is reflected on the x-axis, I should have get a curve go like this, isn't it? Are you following that? Can I confirm the graph is reflected on the x-axis? Look at the shape of the curve. The green curve look like similar to the red curve, isn't it? So 100% sure that A should have a negative value. But the question is what is the value of A? We don't know what is the value of A yet. But we're going to find out a couple of things. So I'm going to erase everything as I marked it. We can clearly see the x-intercepts. What is the x-intercept we find out? This is 2, this is 4, this is 6, this is 5, isn't it? So my function is A times 2 to the power of k x minus d plus c, which I find out 6. What I know about it, when x is 0, we know the y value is supposed to be 5. So 5 is equal to A times 2 to the power of k, x is 0, and then minus d plus 6. So I move that 6 to the other side. Negative 1 is equal to A times 2 to the power of 0 minus d is minus d, kd. Are you seeing that so far? I can create an equation based on the value. Now the question for us is, how do we obtain the k value, A value, and D value? There's a couple of things we can do. There are certain points I can read from the graph. So I'm just going to squeeze it to talking about certain points that's on the graph. We can easily see it. Let's moving back to the original function one more time. This is 1. 2 is going to be 4. And then as I said, when I reflect on the x-axis, supposed to go like that. 2 is equal to 4, so it's going to be, it should be go like this. Now, we want to see, does the graph, by looking at it, so you can see, we can clearly see this graph is shifted upward, isn't it? Which gives the vertical asymptote we got a 3. Now the question here is, do you think the graph has been stretched or compressed than the original graph? So let's look at the red curve. The red curve is y is equal to 2 to the power of x, isn't it? Look at the blue curve. Did you guys think that the blue curve and the red curve has been stretched vertically or horizontally, or is exactly look like moving my red curve up to the blue curve? How the shape look like? Let's look at the points. What? It's stretched. It is definitely stretched. So how do I able to find the A and D value? We need to choose some couple of points on the graph. So we're going to going back to find more points on the graph. So what are the points we should be able to find? And let's read it from the graph. Oh, that's... Kevin, can you hear me? Definitely he can. Because
Yeah.
I thought my internet went out and come back. So I'm gonna going back to choose another point. So we know there's a point when x is 2, y is negative 8. So you can see that. So we already know the value for the c. So y is equal to A times 2 to the power of k, x minus d, and then plus c, I say 3. Let me plug this point. So what is this point? 2 comma -8, isn't it? So when y is 2, I mean not y is 2, when x is 2, y is -8. And so it's going to be -8 when x is 2. So let's move the other side. -8 minus 3 is going to be -11. 8 times 2. I can't really do anything k, 2 minus d. So that is one equation I can create. We also create the equation for the x-intercepts. I'm not sure whether that guy is sitting here. I got -1 is equal to 8 times 2 to the power of kd, isn't it? Equation number 2. Are you guys following so far? Hello. Okay. Now we need to find another point because we need to find A, K, C, and D. I find a D, but we need to find A, K, and C. So the next equation we should be able to create. So we need to plug another point. So we're going to go back to see what's the another point we should be able to plug it in. So I find -2 comma 8. I can also plug another point. Let's see, where can I go? So we should be able to read the point here. So that is 2. This is 1. I can't choose that point. I already choose this point, y-intercept. So we got these two equations. -11 is equal to 8 times 2 k2 minus d plus 3 and -1 is equal to 8 times 2 kd. I can't really find anything using these two. There's one more point I need to try to see where can I get that point. Okay, I'm going to revisit that question to see how can I get one more point, because I don't want to estimate this. This is 2. And then this is not going to be 1 because 1 is here. That can be 1.25. Yeah, we will come back to that particular question later. Now let's going back to the thinking question. State the transformation necessary to transform. It's going to be is an indirect question. We used to get how to transform f of x to something, but we want to transform this guy back to that. So this is the most common thinking question. F of x is equal to 1, 2x plus 1 plus 5 to 1/2 2x. So let's going back to see how do we do this. So first of all, if you look at the 5 here, do I have a 5 in here? No. So we're going to do a reverse process. So if I'm going to take the f of x, and then if I'm going to vertically chip down by 5 units, I can get rid of the 5, isn't it? Plus 5. So my first step, vertically translate 5 units down. Vertically translate 5 units down. So if I do that, the 5 is going to become 0, isn't it? So let's ask Harsha, what else I can do to reverse it? So look at these two functions. What is the next operation should I perform? Because I don't want the 1, isn't it? So what 1 does to the actual graph, plus 1? Other way, what is the transformation called? What is this transformation called? Correct, horizontally. Horizontal translate
to the left.
to the left by. So how do I reverse it back? That's right. So we're going to do horizontal translate to the right by. Horizontally translate to the right by 1 unit. You can see that how I'm reversing it. First I reverse the 5, now I reverse the 1. Then what should I do? vertically compressed by a factor of 1/4. That's nothing I can do. I can't reverse it. It is not there. Vertically compressed by a factor of 1/4. Now, very important. You need to go in this order. If you do the other way around, you're going to get a different graph. So always we go back to vertical translation and go inside, isn't it? The last transformation we do is always moving up and down. So when I reverse it back, we will first reverse the up and down, right or left. Are you just following that? All right. Now I can moving back to my applications. We will go back to the next class. So we're gonna moving back to easy one. It's called solving exponential equations. But before we do that, I gave a lot of practice questions here. How many of you really did those questions to the practice? I know you don't have a hand in it. Okay, that's a good excuse. Okay, simplify using exponent rule. And then leave the answer in positive exponent. I will do it. You can do the textbook question because they're not easy. So first one, when we multiply, did you find it, sir? When you multiply the same bases, what should I do for the exponents?
Sorry, what did you say?
When you multiply the same bases, what should we do for the exponent?
The same?
Now, if you have a same basis, when you multiply, so if you have a same basis, when you multiply, what should I do to the exponents?
You add them.
Add them. So we're gonna do -4 plus -6 divided by power of power -2 times 7 is -14. This is n -10 over n -14, isn't it? We're gonna simplify this. -10, -14. N to the power of +4. All right, let's do the little complicated one. D. So when you have the 4 outside, what is the exponent, Harsha? When you have the 4 sitting outside like that, what is the exponent? When you have the 4 inside the square root like that, what is the exponent? That 4 is telling the exponent is 16, sir. What is that exponent? We talk about that. When you have a 4 sitting there, what is the exponent? Aadarai? You were away. Guys, when you have square root of 16, it's 16 to the power of 1/2. When you have a cube root of 27, this is 27 to the power of 1/3. When you have an n root of x, is x to the power of 1 over n.
4.
What?
1 over
Yes. So it's 81 p8 to the power of 1 over 4 divided by 9p to the power of 4 to the power of 1/2. Because it doesn't have anything, then by default it's 1/2. Are you seeing the picture? All right. Now we're going to be apply the distributive of the powers. So it's 81 to the power of 1/4 times it by p times 8 times 1/4 divided by 9 to the power of 1/2 times p to the power of 4 times 1/2. Everyone doing that so far so good? Yes? Using your calculator, can you tell me what is 81 to the power of 1/4 is?
Oh,
81 to the power of 1/4.
I put 20.
Okay, so 81 bracket to the power of,
I didn't put the bracket. Wait.
again, you didn't put the bracket, so now I'm going to go back to the exponent button. This is the exponent button. 1/4, 1 divided by 4, that should be 3,
Can I see?
right? Okay, so You all have a different calculator, so you should know how to do that on a calculator, which is going to be 3. This one, we can't really do anything. That is p squared. So what is 9 to the power of 1/4 on your calculator?
Got it.
I mean, 9 to the power of 1/2. My bad. My bad.
It's 3.
3. Correct. Now this is 4 times 1/2 is 2, isn't it? So Kavya, if I simplify that, what should I expect it to get?
Simplify the p squared.
If I simplify that, what is that equivalent to? Azure. Okay, Azure, what is 2 divided by 2? 4 divided by 4?
1,
A divided by A?
1,
4A divided by 4A?
1.
1. You have the same thing on the numerator divided by same thing in the denominator. Why you guys stop thinking? All right. Well, we can apply the rule. 3 divided by 3 is 1. P to the power of 2 minus 2 is p to the power of 0, which is fine. I'm doing it because they're not easy, so that you can do the practice questions. So on the textbook. All right, let's go back to the next one. When we multiply the same basis, what does the rule says?
That's true.
When you multiply the same basis, what does the rule says? At the
Add the exponent.
exponents. Do we have the same basis? Okay, we're gonna add the exponents. Ten to the power of p minus 8. Kevin, are you following that? What's happening, sir?
Yeah.
All right. This is going to be x to the power of 4n minus m. Now we're going to distribute the exponent. When I distribute the exponent, it's going to be 1 to the power of, 1 has an exponent 1. We're going to multiply these two, m plus n, over x to the power of 3 times m plus n, power of power rule. So which is x to the power of 4n minus m. 1 to the power of anything is always 1, divided by x to the power of 3m plus 3n. So x to the power of 4n minus m minus 3m minus 3n. X to the power of 4n minus m minus 3m plus 3n. So 4n plus 3n is 7n. Minus m minus 4m is minus 4m. Are you seeing the picture? Yes, sir.
For the question before, can't you simplify that?
Oh, yeah, I didn't simplify. 10 minus 8 is 2. A to the power of 2 plus b. Thank you. All right. Before you guys evaluate, I want you guys to simplify this expression a and b. So I'm just checking where I am in here. I'm on there. I'm on track. Solving exponential equation. Oh, yeah, I will finish this. So can you guys do these two for me? Example 3, a and b. All right. I'll be back. Simplify first. Do not substitute. Just simplify using exponent rule. And I want to see just time to time touch it so it won't go up. Oops. All good. All right. Let's see exponent rule, how that's going. Let's see. I say do not substitute, simplify. All right. But you guys didn't listen to my word. I say just simplify. Someone light went off. Oh, so it's probably on timer. That's not quite right there, sir. I'm not sure how did you making that mistake. And then what's happened? After that, it's stuck. You guys need a lot of practice. Okay. Let me see how you're doing, sir. I say do not plug in the values. Okay. Let's simplify the expression. So I'm not sure. So let's see how far you've done on the simplifying process. That's not quite going near. So if you see in this part, so you got a to the power of 5/2 on the numerator, isn't it?
Yeah.
And then that exponent 2 will be distributed. How do you get 10/4? Because it's 5/2 times it by 2.
Oh, I just want so sure.
All right, so let's show you what to do there. All right, you did partially right, partially it's correct. So I'm not sure where does the 25 suddenly come in the denominator. So this exponent will be distributed to the 3, b to the power of 6. And that 2 will be distributed to that 2, 5/2, times 2a to the power of 4, b to the power of 5. So this is b to the power of 6. This is a to the power of 5 times 2a to the power of 4, b to the power of 5. Kaja, how did you get 11 for b, man? This is on the numerator 5, this is 6. When you're dividing, you don't have the exponent, you subtract the exponents.
I thought it's multiplication.
It's multiplication, yes. But where is the b sitting in there? Where is this b sitting?
Oh,
So that is going to be 6 minus 5 times 2, a to the power of 4. When we're dividing, we're going to subtract the exponent, which is b times 2, a to the power of -1. We don't want to write a -1 as a -1, so it's 2b/a. Positive exponent, switch it back. Now substitute. B is 3, a is 2. Let's turn around to be nice 3. When did you guys learn exponent rule? Grade 9, yes. Some teachers straight away, let's teach you exponent rule, right? But after that, grade 10, there's no exponent rule, but it comes in a quadratic and binomial when you multiply. But you should be very good in the exponent rules. Are you taking any summer class, summer school?
No.
No, so you're taking a break and learning advanced function. And oh, you're taking grade 11 function first semester, grade 12 advanced function second. How about you?
I'm going to either do English or physics in summer school.
Okay, so doing physics in summer school won't help. If you really want to pursue something related that requires physics,
Yeah, my field doesn't require it. It's just recommended.
What program you applying to?
It's just like science.
Regular sciences?
Yeah, so they just said recommended.
Okay, so regular sciences, but what do you want to do with the regular science?
I want to go to like law school or whatever. So,
Okay, so you just want to go to law school. All right. So now kind of deviating from math, I believe. Right?
yeah,
Okay. And then how about you?
no idea.
No idea. So we will wait and explore it. Okay, that's worked out too. But I will say that when you're choosing the courses, it's always better to have a mixture of courses. So okay, so physics is recommended because I'm learning physics in summer school. Technically speaking, only one unit can be taught on that 17 days, dynamics. You cannot cover all the unit. Okay, let's go back to how to work with this. We're going to switch it back to exponent form. So AB whole thing squared over A squared B cubed to the power of 3. Otherwise, what should we go outside? What should I put over here for the exponent now? I want to put that in the exponent. I'm getting rid of the sign. What exponent should I put? Kevin?
Mm,
Kaushik?
D squared.
Just a few minutes before we talk about it. Didn't I just show a few minutes before what that means is? When you have the square root of 16 and show the exponent is 1/2. I know you're all hungry. I'm hungry too. Okay. Exponent must be 1/2. It's a square root. A square root have an exponent 1/2. You cannot forget that. Except the square root, if you put any other number, we can rewrite back to x to the power of 1 over the number. I just follow that. So what do you have to do first? So you see a lot of things sitting here, right? Should I multiply it by 1/2 first inside? Yes? Yeah? Because power rule. But in your grade 6, 7, and 8, your teacher had been saying bad math. There's a B in there. Do we do the B first? If you do the 1/2, that you're doing the exponent, but we didn't do the B first. There's something inside the bracket, isn't it? You had to simplify that. So let's work with that guy. So 9b cubed. This is exponent 2 will be distributed here, a to the power of 2, b to the power of 2. This 3 will be distributed here, a to the power of 6, b to the power of 9. And then my 1/2. I'm not done yet. I'm going to simplify all of these guys. So 9 b to the power of 3 plus 2 is 5. And a to the power of 6, b to the power of 9 to the power of 1/2. All right. Now I'm going to apply my exponent rule. This is 9. A to the power of, when we are dividing, we can subtract the exponent. When we are dividing, we can subtract the exponents. So 9, a to the power of -4, b to the power of -4 to the power of 1/2, isn't it? Is everyone following that so far? Kavya, Gaushi, Adrai. Okay, now we're going to multiply it by the 1/2. Do not forget that 9 has an exponent, 1 is hidden. So 9 to the power of 1 times 1/2, a to the power of -4 times 1/2, b to the power of -4 times 1/2. So Harsha, what is 9 to the power of 1/2 is equal to?
Is it 18 then over 2?
So remember, there's a 2 simple. This is the same as 9 to the power of 1/2. 9 to the power of 1/2 means square root of 9. They're equivalent, isn't it? Because I just few minutes before I say, when you don't have the 2, rewrite it exponent 1/2. So 9 to the power of 1/2 is square root of 9. How much?
Oh, 3.
That's right. And this is going to be a to the power of -2, b to the power of -2. This is going to be changing back to 3 times a squared b squared. You're changing this exponent to positive exponent form. Makes sense? Are you guys following that? All right. So come back to the next part. I don't really want to go about right now, but I'm going to show you what that is. So on a textbook, this section in, so you guys going to do 4.6 textbook questions, 4.6 all about graphing. 4.5 is nothing yet. There's no practice there. It's about the properties of an exponential function. But you need to do 4.3. 4.3 is everything is about simplifying the exponents using exponent rule. So let's do some practice before we move on. I want you guys to do number 5F. Number 5F. Number 5F first. Copy down number 5F. Of course it's ugly, but that's okay. How would you do number 5F? Anyone went to watch the Minecraft movie? So it's not the Minecraft fans? No one played Minecraft? Okay. All right, let's see. How would you guys do that? Copy down that first carefully. There's so many brackets here. Sorry? Well, you're doing a different question, but that's okay. I asked you to do F.
Oh, I did.
Okay. Let's have like copy it down.
Yeah.
And then after that, there's a -1, not -2. I'm not sure why do you get minus. Hold on, Kevin. Let me take that in. I just gonna show that quickly to wind up the class. All right. All right. So this one, oh, where does this go? I took the screenshot. I'm not sure where they go. You know what? We will take it up next class. So that is 4.4. There's a lot of questions in 4.4. I need to show you something that a great resource. You all know where to sit. So CEMC grade 11. Search CEMC, Center for Education in Math and Computer Science in Waterloo, has created a complete package from grade 9 to 12 resources. We are on exponential and trigonometric functions. So if you access this, you can see that introduction to exponent function, properties of the basic exponential function, transformation, and modeling. Especially the transformation is one of the challenging units. If you click on that, guys, so write it down, CMC grade 11, you will see somebody really talking about what's happening on a video lesson.
Phenomena that can be described using exponential functions are very common in nature. However, these descriptions
And then good news is you have tens of questions to practice if you want to master the transformation, and followed by exercise and solution. Do you know the resource? Huh? CEMC resource?
Yeah.
Okay, did you guys use in school?
No, you just told us, right?
All right, your homework for Kevin, chapter 4.4, 4.5 is nothing there, 4.6. So 4.4 and forward 4.6, we will talk about solving exponential equations and then application of exponential function next class. That's being said, following week, or maybe next week, I will start with the trigonometry.